And we're off. Hello, everybody. How are you doing this week? I'm hoping everything is working. I've kind of built a little studio right here in my wife's coffee shop this week. So hopefully there won't be any glitches, but you know how that goes. There always are. Every time you go live, there's glitches. So I'm just glad to be online. I don't know how you guys feel about me switching to Monday nights. I kind of did it as a fluke one night, and then it just kind of went really well. So um, other than last week when I kind of messed it up. But other than that, it's gone really well. So I thought I would keep it for a little while and see if you like it. We'll keep it that way. If not, we can always redo it. And man, do I have a packed show for you tonight. I've got a couple of really cool things that I want to do tonight. And I want to make sure that I keep you involved in all the things. Sorry, I wanted to step off the screen and grab something for a little bit here in a few minutes, but that I forgot to pick up before we started. But I've got a packed show loaded full of cool information from both the standpoint of the DIYer and general solar in general. So without any further ado, let's get straight into solar news as we always do. I found this really cool article this week, and please, CJ, I see you. Let's see if I got my chat working properly. Let's try that. See if we can get that to work this week. I think it's this one here. I'm hoping that did it. And it is. Hey, CJ, good to see you. Peace to you too. Glad to see that chat is working this week. And hopefully it'll stay working throughout the whole show. But you never know how it goes. You know how that is. So I've got some really cool news for you. And anyone who's interested, there's probably not links below. I think I forgot to put them in the show notes. I will add them to the show notes. I will include a QR code here for everyone. At least I think I will. Let's see if I can turn that on. I think it's this right here. There it is. This QR code will take you to a web page on my website that has all the links, and I will put them in the show notes after the fact. I think I forgot to put them in there. I might have, but I don't think I did. I built them at the last minute earlier today. I thought, oh, I forgot about the show notes. I forgot about the links, and it's just some affiliate links to different equipment and stuff that we'll talk about tonight. And if you have any questions or if there's anything that I forgot to put in there, please just let me know. I'll be glad to get it added. They are affiliate links. I do get a little commission off of them if you do buy something, so I appreciate you using the link if you're going to buy something. And with Christmas just right around the corner, I included some really cool things, and I do want to mention also that Signature Solar right now has a special going on. I got an email from them, I think it was either today or yesterday, where they're doing the flat rate shipping over, I think it was over $3,000. I think it's for like $200 or something. So if you're going to be ordering batteries or inverters or anything like that, I put some of the really cool stuff down there for you. So do it now, because even if some of those items, they run out really quick, and when they run out when they do sales like this, because of the free shipping, you can still guarantee the prices. You just have to wait a couple of extra weeks. And with the solar credit coming to an end at the end of the year, you don't want to put it off it too long. So anyway, let's get on to the news, and let's talk a little bit about something interesting came out from Solar Edge. And I read this and I thought, I don't even know how this would work, but I thought it was really interesting. Solar Edge expands virtual power plant. They're calling it the VPP program. So basically, Solar Edge Technologies has rolled out 500 megawatt hours of residential battery storage into a virtual power plant program across the U.S. in 16 states and in Puerto Rico. So these networks are, and I'm reading right now, and we'll talk about it here in a second, but these networks are thousands of small systems, solar and plus storage, that work together to support the grid during high demand, while homeowners earn compensation for providing storage power back to the utility. Now, when I first read this, I thought, that's a pretty cool idea. So basically what they're doing is they're hiring us to be little power plants and to store this power, and then when they need it most to keep the grid up and keep it functioning, they're buying it back from us. Now, if they don't screw us like they do all the time with buyback programs like this would be really, really cool. They didn't actually give a list of all 16 states, and I dug a little bit for it. I thought, I'm going to figure out what 16 states it is and see if I'm part of it, because I would like to be part of that. I have, as you all know from the video I released earlier this year, or earlier this week, last week maybe, I do have a solar edge in my house, and but the only states that they had listed on it was Arizona, California, New York, South Carolina, North Carolina, Connecticut, Washington, Colorado, and Puerto Rico. The territory, not necessarily a state, but um, so right now they're saying 16 states, but they've only got the what is that? 1, 2, 3, 4, 5, 6, 7, 8 states plus Puerto Rico. So for all practical purposes, 9 states. So either way, uh, that's interesting. That I just found it really cool that they're finding ways to use the battery power that we already have out here to help supply power to the grid. Now, not it wouldn't be everybody's cup of tea, but I thought it was a good idea for them, especially in states, and California's listed there, and New York's listed there, in these states that are power hungry, starved, and they've already raked these people over that you guys in California and New York that are getting solar systems installed, especially that's grid enabled and with batteries. You've already been raked over the coals, and basically it's very beneficial to you and to them. So I thought that was really cool. Um, so I want to take a brief moment before we start tonight and go over some really important items that when I was looking through the news, one of the things that I've been working with, and I don't know if you guys are familiar with this book right here, but this book right here is the National Electric Code. And I just want to make sure that I cannot ever stress too much just how much this does include you. Just because you are doing things that are not, because you're doing things in a DIY manner, that doesn't mean you should be sidestepping some of the code that comes out. And the electric code is there for small. They've got pieces in it that are for small scale people, just like you and me. They've got pieces in it that are for full size solar farms. It's got pieces in there for inverters and fuses and breakers and cable wires and stuff like that. Now, as you can see, it is really extensive. And there's a lot of details in it. And it took me, I don't know, a couple of weeks. I've spent the last couple of weeks just kind of going through it, kind of trying to figure out, what areas really pertain to us. So I worked for quite a while and came up with a list of sections that I kind of want to just give you a brief idea of what they are, and I'll try to keep it short, and then we'll get into the main content tonight, which I do want to highlight what the main content is for you guys that are waiting for that. So I've got a show here that's going to basically go over. We're going to go through inverters. Then we're going to cover some fuses. I'm going to show you a few of them. I've got an EG4 inverter here to kind of show you. I'll give you a picture of it. So I've got a close-up of it and how it's going to work. I've got the whiteboard. I've got a bunch of fuses and breakers that I brought in, or I've got some pictures of some of them, and I got that are installed in systems that I don't have multiple of. And then I've got others that I've brought with me that I can actually physically show you to them. So we'll go over fuses, breakers, and disconnects. There is a lot of confusion between the three. They all three serve some of the same purpose, but they're all three designed for different things. So we'll go over them and talk about it. But it's really those 4 items that I want to talk about because they're what protects your inverter and makes your system safe. And then if you understand some of the NEC code to go with it, it hopefully will make you a bit safer. Now, I want to give a little bit of a disclosure here. This is my interpretation of the NEC code. I am not an electrician. So please, if you're not comfortable with what you're doing, then don't do it. Hire an electrician. That's what they're there for. They spend a lot of time in schools and classes going through this. There's apprenticeships and all kinds of stuff in order to get approved and stuff like that. And this book has a lot of details in there that are really interesting. So let's get on with it. We're going to talk about first Article 690. Now, Article 690 talks specifically about solar systems. So 690.1 is the scope of a solar system and that kind of stuff. And then you get into 690.12, which talks about rapid shutdowns in PV systems. And these are the specifics that they get in. And I am highlighting differences in the code. Now, the NEC book comes out, you'll notice here there's a date. It says 2023. This book is released every 3 years. And so there is a 2022 book, a 2017 book, a 2014 book, a 2011 book, and so on and so on and so on. Many states don't adopt this book right away. Here in Florida, I think we are adopting the 2023 book in January of 2026. So it gets adopted next year. But there are a lot, and I think I actually wrote down some of the statistics on how many there are that do this. So the variety of states mention that 20 states have adopted this, 19 are still using the 2020 book. So as you can see, even if you are one of the states that this pertains to you already, there are code changes in these sections that apply to you. And if you're not one of those areas that are using the 2020 book, then you're going to want to take close attention to these because they will affect you. And so this book is designed to really give you the safety standards on how to hook things up. Now, this is not the law. This book's interpretation of what should be done in these standards is law made by the state. So you may have additional state laws, county laws, or city laws in addition to this. They suggest the minimum standards, and that's what most states go ahead and adopt what's in this. And in a lot of states, they go beyond this and make it even more stringent. But anyway, I just think it's really important that we focus a little bit. Just because we're DIYers, you hear it all the time. Oh, you're DIY. You're going to do this. You're going to do that, and that doesn't mean that we aren't safe. That doesn't mean we don't follow the rules. That doesn't mean that we don't do it with the proper codes in place. It doesn't mean that we don't do things. That also doesn't mean we don't make mistakes and that we shouldn't learn from those mistakes and make them better. The reason I bought this book was because I kept hearing, well, NEC code this and NEC code that and NEC code this, and I wanted to read for myself firsthand what are these NEC codes and how do they affect me and how I never dreamed that I would find entire chapters in the book, section 690, completely dedicated to solar systems. It goes on in 690.31 to talk about wiring methods for PV systems, specific conductor types, insulation ratings, protection from physical damage, separation of DC circuits from other wiring, as in AC wiring and other types of circuits and stuff. There's wiring gauge, conductors, protection requirements, all kinds of things that explain to you if you're going to install your solar system on your roof. When do you need to use conduit? Do you need to use EMT conduit? Do you need to use PVC conduit? What do you need to run your solar system underground? How is it to run it safe? What kind of PVC? When can you switch from PV wire to regular electrical wire? When you want to penetrate into your house, what kind of penetration do you need? What kind of conduits and conductors and stuff do you need there? So this is what the rules and the guidelines that the NEC sets down is what your state has put into law. And just because you're a DIYer, I really want to stress the fact that that doesn't mean you just skip all this and do anything you want willy-nilly, because willy-nilly gets people hurt. And that's not what DIY is about. We're about saving some money and doing it ourselves, but that means we're still going to be doing it right. We just don't know what right is yet all the time. So that's why we help each other, we educate each other. That's what this channel is all about, is learning solar, learning the rules and getting things right. And you're going to see me take a huge endeavor into this area and become more and more a realist of what does it take to make a solar system. And you've always heard me talk about it, but I'm going to really follow up on a lot of the codes and see what it takes to hook things up the right way and understand the codes and explain the codes to you so that you also get that benefit of having them. In section 690, and all of the sections that I'm mentioning, all of these have changed from 2020 book to the 2023 book. And that means that, yes, that means that there is a new book coming out in 2026. And if you're looking to purchase one, these books are extremely expensive. I don't remember what I paid for mine, but they run somewhere around $150 to $200. So you're going to want to look for a used one. And sometimes that takes time if you're trying to buy one. But the majority of the content of the book stays the same, and you'll see that there's only a few things in certain chapters that change. This one has a lot of content change for solar systems because it's taken on such an enormous part of our environment and our life recently. So I'm going to take that QR code off the screen for a little while. If there is somebody who needs it, please let me know. I'll turn it back on, but it is very distracting, and I'm sure it is for you too. For now, I put it up there because I did not have it in the comment notes below. So if you're interested in those links and stuff like that, right now the QR code will take you there. When I finish the show, it'll be one of the first things I do is post all those links into the show notes because I completely forgot to do it before the show started, or at least I think I did. Um, and I'll turn it back on periodically through the show so you get it. In 690, I get this question all the time, talking about equipment grounding and bonding. In 690.43 of the NEC book, they talk about detailed grounding rules for PV module frames, metallic raceways, and enclosures. Now, obviously, this is extremely important from our perspective. Everyone has grabbed that refrigerator in a neighbor's house or whatever and felt that little tingly feel, or touched that, that device and felt that little tingly feel. Everyone has had that GFI plug. Every time you plug something in, a certain device, it pops. I know in the hurricane last year, the most frustrating thing for me, beside the fact that I had an RV that was completely off grid, stuck in a flood, and I couldn't get to it, and I was running on a generator in a house with no power because the solar system shut down because the grid went down, and when the grid went down, I lost the solar system. So I was running off of two solar panels and a 24-volt battery, running my solar, and I was running everything else off of a generator. Now, fortunately, I had the food tuck generator there, and I had one of those power stations that you get from um, Home Depot or Amazon, where you plug it into a big 50 amp plug and it turns into a whole bunch of wall outlets and stuff like that. And it worked fantastic, except all of the plugs were GFI, and that damn refrigerator I had wasn't properly grounded. And that damn thing would pop that GFI plug. I bet it popped every 6 hours on average. And that meant that, if I got up in the middle of the night to go to the bathroom, I had to go out and check the stupid GFI plug on the refrigerator, because even though I had the generator running, I still had to make sure that the stupid refrigerator hadn't shut itself off. But grounding happens in that chapter. Then we got chapter, let's talk about, was that the right chapter? Yes, it was. So then we got chapter 705.11, which talks about interconnect electric with power production sources. A lot of you guys ask, what does it take to get grid connected? Chapter 705 is exactly about sources for connecting to service, covers how PV systems connect to the main service, including on the load side, the supply side, what the rules are, how you should do it, and more importantly, how you should do it safely. Going on from there, in 705.12, it talks, there are changes in the code book, the 2023 code book for load side connections, explains the 120% rule of breakers and buses and things like that. There's specifically some that allow for the backfeeding into breaker boxes. There's been changes there on where that breaker should be and how it should be connected to backfeed into panels in order to get a better rating, and what you should rate your wire, not just to manage the amps that you're putting out, but to also allow for that buffer that you need to stay safe and limit it then. Then section 705.31, disconnecting means from the interconnected system. Requires disconnects to be isolate power sources safely and access from utility workers. In other words, a lot of people don't realize that not only do you have to have a shutoff outside, but it has to be accessible to the utility workers to be able to physically turn it off. You can't lock it on. You have to make it to where he can shut it off, and they even prefer where he can shut it off and he can lock it off so that he can work on the circuits around the area and stuff like that. But little things like this are really easy when you're hooking up a system the first time, but you don't know what you don't know. And that's what that's why I'm going to take on this enormous task of looking through this book and understanding these chapters and bring some of this content bleh, bring some of this content to you um, in a way that's educational and helps you build your system and build it correctly. Also, there is a chapter 706 that talks about energy storage systems and how to disconnect batteries and how batteries need to be connected and how they need to be accessible and where they need to be accessible. And it applies a whole new section on the lithium section of this. So this is really one of the things that I wanted to cover before we get into the real show. But I wanted to kind of give you guys a highlight of what's in it. And as I read through it, I'll be sure to bring a lot of this content to you and bring you especially the important chapters and pieces that keep you safe. And hopefully we can learn a lot of this together and make our systems safer and better than they were before. Now, that said, I have got a packed show tonight, and it is going to be all about one of the most one of the most overlooked pieces of a solar system is the protection devices, and that's what today is all about. We're going to start off talking about inverters, and then we're going to take that and we're going to stretch that into talking about breakers, um, fuses, and disconnects. And I'm going to use this inverter that I have here as as an example of how to connect this and where you would put your disconnects and where you would connect these type of things for when you are building your system so that you understand what is really necessary to make that work for you. Now, I want to start off by looking at last week. I think I have last week's. I built a diagram that kind of highlighted last week's live stream that talks a lot about, at least I thought I did. There we go. Where am I going here? Let's see if I can find it here real quick. We talked about the two sections and the four main components of a solar system. And I should have got this document ready before we started everything here. Sorry about that. Here we go. All right, so I think if I put this on this screen, let me see if I can get this to share correctly. Sorry about that. There we go. Here we are. All right. So here it is. Oh, I got to switch the screen too. There we go. All right. So it is not showing it. Why is it not showing it? Wow, that is really weird. I had this problem before, but never so blatant. All right, let's try this a different way here. See if I can get, that's not even showing up either. Huh. All right, then we will have to try this a different way. Wow, I cannot get it to show that screen no matter what. All right, so I guess we won't be showing that. I will post the PDF in the show notes and give you guys a link to it. But it's basically just a diagram. Oh, I bet I could show it on this screen. I bet I can. I'll bet I could show it on this screen. Give me just a second, guys. I really want to show this diagram. It's really useful for you guys. Screen capture. And let me just change this device to this screen. And okay, and then let's see if I can get this. Did that show up? It does. Ah, good. Okay. So here is the diagram that we built last week for on the live stream. And it basically went into the DC side of all of the circuits, starting with the panels and how the calculation went for calculating amps and how you could use this formula to get back and forth from volts to amps to watts to all of that with Ohm's law. And then we went into the MPPT charge controller and how to register to understand the inputs and the outputs of a charge controller and what the voltage range would be and what this amp rating would be. And then we went into the battery and different charging profiles and stuff with it. So the one thing that I didn't cover, and I only put a couple of boxes out here for this, was um, uh, the one thing I didn't cover is I put a few boxes out here for the for the fuses and breakers, but we didn't go into it in detail. So this week we're going to go into it a little bit more in detail, and we're going to talk specifically about the piece on this screen. Well, this makes it really difficult to share this properly when I have to do it this way. Let me see if that actually, I think that works. Yes. So we're going to talk specifically about this piece right here at the inverter. And this piece that splits the difference between connecting to the battery up here and going to the AC. And I want to make sure that I put this little chalk line between them here that really highlights the difference between that top part, which is the DC voltage and all of the DC connections, and that bottom part, which is AC voltage. And all the connections there. And then we're going to go into the different fuses and breakers, and I'll just explain what each one of them is. So let's start with the looking at an inverter and go from that first off, because that really does don't know where it is. There it is. Okay. So let's talk a little bit about the inverter first, because this is this piece of it here that we really want to cover first. So I'm going to switch this screen over to the inverter picture, and I'm going to walk over here to the inverter, and we're going to talk a little bit about what some of the connections going to the inverter are. So you'll notice here on the inverter that we have several different inputs. Now, I did not put the camera down where you can see this, but I'm going to pull this down to the bottom of this so that you can see the bottom of this inverter. And you'll notice here it's got inputs for the battery connections, which go in here. And then it's got PV in over here, AC out, and AC in. So these are your three big power sources, and if you relate this back to that diagram that we were looking at, which if I can, let me see if I can pull that back up on the screen for you. Let's see if I take this and I put it here. Maybe I can find a way to shift back and forth easily here. Let's see here. That's not it. Always something, isn't it, guys? All right, there we go. All right, so I should be able to come over here to this screen and do that. And hopefully that will switch to the solar drawing. I gotta wait for it to get sent out to you guys so that I can actually see what it's broadcasting, because I'm using my broadcast screen to see it. So unfortunately, there's not a whole lot I can do about that. But so this is going to be where we are working at, is that inverter piece, and we're looking at specifically the battery input, which is this piece over here. Is this input over here. So the battery connections come in here and connect right here through these terminals is where you would tighten it down. So that's where the battery cables. Now this system, this inverter comes with several key components that you would need to connect it. And I've got them sitting here, and I just kind of want to show you a few of them so that you understand. So the battery comes with the battery cables, as you can see here, comes with the nice square connectors on here so that they can go into that battery connection there and be connected and terminated in there and tightened up really easy. Now they made it very, very easy for a screwdriver to fit down in there and to get to those lugs, and this goes in this hole here and fits directly in there. And so these would go in just like this, and I don't know if I can show you how they would actually connect, but you can see that they go in and then they just go right into those lugs and they would just tighten down. So they send this to you already prepared to plug in there. Now, not all of them do that. You have to build some lugs and stuff like that on some of them. But these cables are made for this inverter, and they make it very easy. Now, the one thing that they did do, which is a little puzzling, and I think it may have been an afterthought, is that they sent also this, in addition to these cables, which we were just, I was just showing you and how those plug in, they also sent this breaker. And you know what, that's probably a better view over on this screen here. So they also sent this breaker. And this breaker would also take a nice connector that size. But what they didn't do is they didn't put a way for you to put it in line. So what you would need to do is somehow take this cable as it comes out of the battery and go into this and then go from this into the connector over there. But you can see here they have included a breaker. Now, let's talk about some of the core differences, and that's where the battery connects. And then we have the PV in, which is obviously going to use PV wire, and then we have AC out, and we have AC in. So let's talk about some of the different devices that are used to keep us safe when we're doing this. So that really is what the inverter has, the connection, as we talked about with in this chart here. It has this connection between that 12-volt battery going to the inverter, and then the connection from that inverter going to, in this case, 120-volt output. So you are touching both sides of the fence. Now, as we learned earlier in that NEC code book, there are some specific codes around keeping these wires isolated and safe from each other in certain things. It doesn't mean they all have to be separated. It just means they have some rules on when you can and when you can't and that kind of stuff. And I haven't gotten into those specifically yet, exactly what all of those are, but you will see that it certainly is a huge enough book that it's going to take some serious work to get to it. So let's get into the types of devices that we're talking about here. So let's start with, we've already determined that the inverter is the central hub of all this. But one of the things that you need to do is you need to understand the difference between the three key components. Now, let's talk about, first of all, we have fuses. Now, a fuse is a disposable item that is set to a specific rating that pops, breaks, snaps, goes out, burns out, fries. Usually there's an element in this fuse, whether it be a T-class fuse, whether it be, and there are several types of them. Let me grab some of them so I can show you. I think I have that bucket over here. Yep. Now, some of these you are very familiar with. So let's look at what they call a blade fuse. Now, most of us have seen a blade fuse in your car or your automobile, And you have probably even had one of these go out before, where you've had to plug in a new one because in this case it's a 15 amp 12 volt fuse, and something in your car, your cigarette lighter, you pulled too many voltages from it or whatnot, and it popped and you needed to get a new one. So this is a definition of a fuse. It's a disposable item, and you can see the little element in there that fries, burns, too much voltage goes through, too much amperage goes through, and it pops it. Now, these are very, very specifically designed for very specific ratings. And you can see from this package here, these are 15 amp blade fuses. And so most of your fuses are going to have not only a amp rating, but a voltage rating. So you can see here, the maximum interruption is 1,000 amps and a 32 volt DC. So you would not want to use this on a 48 volt battery. And it would work with a 24 volt battery because that's going to be up to 28 volts, but it would not want to use this on anything else. These ratings are very, very important to understand, that when you look at something like this, that A, you want it to pop at whatever rating this is, but that's when it's going to pop. How much amperage, if it's shorted out, how much amperage can your battery provide total is where this becomes very important. At 1,000 amps, so if you've got 5,000 amps worth of 12 volt battery, this fuse will not be able to stop the arc, and the power will jump across even when this thing burns out, and it'll just keep arcing across and burn this whole fuse out and fry everything on it. So you've got to be very, very careful that when you're looking at fuses that you're looking at that. So let's look at another one. These, you've seen me talk about these before, where we hook up a battery. And with these, this fuse comes with a replaceable element. And I want to put this back on that screen over there. I didn't realize how useful this screen was going to be tonight, or I would have set it up in a better spot for me. So I'm going to just kind of ad-lib some of this as I go along here and move this around and see if I can get us a good view of that right there. Excuse my feet in the bottom. So, but you can see here, these are made to be mounted on a battery, so a battery terminal would come down here, and then you would take this off, and you put the fuse on. Now, this fuse, just like the other one, says 25 amps, 58 volts. Now, that means that when it pops, this piece is thrown out, and you need to put a new one back in its place. Now these can be a little bit more difficult to get into place, but you put them in, at least I think you do, there you go. You put them in like that, and then you put your battery cable. We're going to use this battery cable as an example. Let me just unravel it here so we can use it as a good example to show you how this fuse works. And then this would be connected like this, and then we would put the washer first. The idea here is you don't put the washer underneath it. What you want is the best connection between this and this fuse as you can get. So the washer goes first to press it and hold it best, then the lock washer, then the nut. And that will make sure that that battery cable is connected to the fuse as best as it can be. And this could then go on a 12 volt battery, and we would have 125 amps at 58 volts. So this would be a good fuse for a 48 volt battery, and usually a 100 amp hour battery would have a maximum pull of 100 amps, and you're going to want a 20 to 25% overcurrent here, which would allow you to have a safe fuse for whatever you're doing and it not pop unnecessarily when you get right there at the edge or you have a small surge. Now this is a fuse, and what I mean by a fuse is we're going to go back to the chart that we're working on up here on the board. Anything that pops, burns out, and has to be replaced. Now, This includes T-class fuses. This includes all kinds of things. Now, what most people don't get is that there is a difference between a fuse and a breaker. Now, let's talk a little bit about a breaker and what a breaker is and how it works. So a breaker is resettable. So you can reset a breaker, and I think I've got a picture of one from our solar shed that I could probably show you. Yep, here's the solar shed one. Fortunately, I think this microphone has some, I don't know if I can get rid of it real quick. Noise suppression there, that might fix it. Okay, that did. All right, so this, if I take this and zoom in on it for you, which I think I can do. Yeah, there we go. You'll see here that there is this fuse right there in the breaker right in the middle. Now that breaker is the 12 volt breaker, 100 amp breaker for the solar shed. Now a resettable breaker comes usually is what you're familiar with probably is an electrical outlet at home when you pop a breaker in your electrical panel, and these work exactly the same, but just please keep in mind there is a huge difference between AC breakers and DC breakers and what they can handle. Some can handle both, and I'm going to show you how to look at the sticker on them and to read them to determine what they can and can't be used for. So let's go back to the over here to the breaker, and I've got this breaker here that came with this device here, and you can see right here it says that this is an AC 230 240 volt breaker, and it's going to have a 10 kiloamp breaking capacity, and it is a 125 amp breaker. So that means that this is not for, as I discussed earlier, the for that. But if you look right here on this sticker, I don't know if you can see that. I'm going to see if I can see the camera. Yeah, you can. If you look right here on the sticker, you'll notice, I'm going to find something to point with here. You'll notice right here, it says 60 to 80 volts DC. So it is 60 to 80 volts DC, 230 to 240 volts AC, and it has a maximum interruption of 10 kiloamps. So that means that this breaker will work for the battery or the AC, whichever side you wanted to use it, up to that rating. Now, it's a breaker. That means that when it's showing green, that means that it's off and it's open, it's in an open place. The line's coming in, but there's nothing going out the load side. When it is red, that means that it's hot and that it's closed, and that means that the flow of power can go through from one side to another. Now, this is only one wire. It doesn't have polarity. It doesn't do both the plus and the minus. And a lot of the times you will see breakers on big battery systems, especially PV systems. And if we go back over to the picture here that I had on, let's see where it is on this one over here, under here, you'll see on the very far right-hand side, I might be able to zoom that in just a little bit more. There we go. You can see here, there is that, I might try to see if I can do that again. Yeah, there we go. All right. And you can see this has two PV circuits, two PV connectors coming out of the top and two PV connectors coming out of the box. That means that it is polarized, meaning that the power has a positive and a negative side. And that's something on breakers and fuses that you want to pay particularly close attention to. Because if you hook up a polarized breaker backwards, it can not work properly. And it can catch fire and it can do all kinds of really bad things. So you want to make sure that when you're working with fuses and breakers that you're paying attention to not only the voltage that you find on the fuse or the breaker, but the type of power that it can handle, whether it's AC or DC. Now, if you look at this chart that I was showing you earlier, let me see if I can get that back up on the screen for you, because I did put the AC DC symbol on here for you so you can see it.
Doesn't mean you should be
so if you look at this symbol here, down here in the bottom right-hand corner of this screen,
and
that
the code,
says
electric code is
AC,
there
and it has this line here
for small. They've
with
got
a squiggly
pieces in it that are
and that is
for small
showing
scale
that
people,
the
just like
power
you and me.
is
They've got pieces
up
in
and
it that are
down
for
sine wave,
full-size
pure
solar
sine
farms.
wave.
It's
It
got
means that
pieces
it's
in
AC
there
power.
for
The power isn't constant.
inverters and
Now,
fuses,
if you go to the top of
breakers
this document,
cable wires,
you'll notice
and
that I
stuff like
have
that.
the
Now,
DC symbol,
as you
which
can
is a
see,
straight
it
line
is
where the power
really
is straight, dotted
extensive,
straight across
and
the
there's a
document.
lot of details
And that
in it. And
is
it took me
DC power.
I
You'll
don't know,
notice
a
that is
couple of weeks.
also true when you
I've
look
spent
at
the last couple of
fuses
weeks
and
just
breakers.
kind of going through
so
it.
if we were to look at this fuse or breaker up close, and I don't know if I can get close enough to see it, but I'm going to try. If we look at it up close, you can see, oh, there we go. That symbol next to the AC, the 240, 250 volts maximum rating, and you can see the 60, what is it, 60 to 80 volts maximum rating for DC. Meaning this is a perfect breaker for this unit to take in a maximum popping range of 125 amps at the 48 volt battery. So this would be perfect breaker for the DC side of this. Coincidentally, this was in the package with it, so it doesn't surprise me that it's the perfect size. But there are tons and tons of different types of breakers and fuses that are available on the market. And so we could talk about a few more of them. So let's look at, this one is quite common. It's what they call an A&L fuse. A-N-L. And you can see here, this is put out by Bojack, and that picture is not very good. I'm going to go back over to this other camera here and walk you through over here. This one's by Bojack, and I just ordered this directly off of Amazon. But this has a protective coating on the outside. I'm not particularly fond of the casing here. They don't seem to hold up to the heat real well. But the theory is this. This is the actual fuse. And you can see here, this is a 200 amp fuse. And I'm not sure what voltage it is. I happen to know that it is rated for 60 volts, but it doesn't say here on here that it is. And I think it was actually rated for much higher than that. But I believe it was a 60 volt one. This was just in one of my bags at home, so I don't know which one it actually is. And so the idea here is to connect it in line here and then have the battery, just like we did with this fuse here, to have this one connect to the other side of this fuse. If I can get it like this. And again, the idea here is to connect the fuse and this connector directly together. No washers or anything in between. You can put a washer on top of here and a lock nut probably, but you don't want washers between the two items that you're connecting together. You want as much of them to touch as you possibly can get, and you want a good fit around the hole in the size of it also. So let's look at that. What I'm talking about here is, if you look at it this way, you'll notice that that hole fits this nut just perfectly. It's not this big hollowed out nut or bolt there, it's exactly the right size. So this is the right size breaker for this particular wire. So it could go like that, and that would be the, and then this cover would go on like this, but this is a fuse. So this is a fuse, this is a fuse. There are small fuses for like little 12-volt systems in your car, like this fuse. There are bigger fuses like T-class fuses, and a T-class fuse will has a very fast rating. Now there is what they call a couple of other items, elements of fuses that you need to be aware of. There is a speed to some fuses that is much more dramatic. And what do I mean by speed? So what I'm talking about is some fuses are very, very sensitive, and react immediately to a particular item, and they're higher quality. They act more precisely within a variance. A lot of your breakers like this, they're working based on getting a particular temperature. They get hot when there's too much amperage flowing through them. They get hot and they pop. A lot of your DC breakers, like we were looking at on this
for myself
firsthand. Well, not that screen. DC breakers, like we were looking at on this screen here, that PV cutoff and the one next to it, that breaker there, those are magnetic pulls, and they'll pull the conductors apart when it's DC rated so that it can actually separate it. DC current is much more susceptible or much more difficult to stop once the connection is made, because the current is constant. With AC, the voltage is up and down, and it's got that sine wave to it where it's literally going from positive 120 to negative 120 and back and forth 50, 60 times a second, depending on where you live in the world. And it's bouncing up and down like that sine wave that you've seen. DC doesn't do that. That flow is constant. And when you get any two things that have grabbed a hold of each other like that, and they're pulling continuously and there's no break, when you go to try to pull them apart, there's no leeway in there for you to yank them apart between the connection going one way and the other. There's no middle ground there. It's a constant tug. So breaking that DC circuit, sometimes, especially in big breakers like not the AC breakers, but the big DC breakers, they will have big magnetic flips and breaks and stuff like that. And the same thing happens in AC, but in a much higher voltage range, and it's much less likely to happen there, or it's much harder to happen there. It happens at a very low rate on DC. You can get very much in trouble with things like that. So that is really the difference between the breakers and the fuses. Now, let's look at one more item that gets confused in here is what we call disconnects. And a lot of people say, oh, well, this is a disconnect. Now, one of the things I want to point out about a disconnect is there is a difference between a breaker that you can turn off and on, that is a device that is really truly designed to protect you from overcurrent, which this is an overcurrent protection device that you can flip off and on like most breakers can be, and a simple off-on switch. A simple off-on switch would be something along the lines of, and I don't know that, oh, you know what, I can find one on Amazon to show you. Let me just do that real quick. A simple off-on switch would look more like, let me see here. 12-volt off-on power switch. Let's just see if I can get one real quick. Why is that not? All right, Amazon. Off-on power switch. Did the wrong search, ended up in the wrong place. Oh, this is perfect. Okay. So if you look at this,
you're interested in those links and stuff like that,
you
right
will
now
see
the QR code will take
that
you there.
this
When I finish the show,
an off-on switch. It doesn't have a breaker. It doesn't have any over protection, over
before the show started, or at least I think I did.
over
voltage over
So,
amperage
and I'll turn it back
protection,
on
or
periodically
any
through
of
the
that
show so
stuff.
you get it.
If it shorts out, it
In
shorts
in
out, that's it. And if
690,
it
I
just
get this
happens to
question all the
stop the
time.
short,
Talking
it's because
about
it's a
equipment
fluke and
grounding
it
and
had a weak
bonding.
spot and it
In
was the weakest link and it popped.
690.43 of the NEC book,
But
they
this
talk
is
about detailed
truly
grounding rules for
a what they
PV
call a
module frames,
disconnect,
metallic
an
raceways,
off-on
and
disconnect.
enclosures. Now, obviously, this is extremely
Now,
important from our
it is
perspective.
required
Everyone has
for your
grabbed that
PV
refrigerator in a
circuits
neighbor's house or
to
whatever and
have
felt.
an off-on disconnect also. And if you remember correctly, when we were looking at that earlier, I showed you that one that I have in that system here. And you can see on the right-hand side, that has a flip switch off-on that you use for disconnecting your PV. Now, this is one of those that is a code requirement that if you install panels on your roof or you install panels in the in your on a mount in the backyard or whatnot, you're going to need to have a disconnect at those panels so that they can be turned off and so that they can safely be disconnected from your system in case you have a fire and the firemen or whatever needs to disconnect it for safety purposes, the electrician or the electrical crew or whatever. So that is truly a disconnect, but it doesn't have your overvolt protection that a breaker or a fuse would come with. So that is your real core difference there, is that your inverter needs to be reviewed at several different levels. So let's talk about that for a minute and where you would use each of these devices. Now, we looked at the diagram and it shows, and we've even looked at the inverter itself, which is this view here. And you can see from this view here, we have a battery coming in here. So this should be protected with either a fuse or a breaker in your system. So we're going to kind of draw a basic little chart here, and I'm just going to put the inverter up on the screen. And we're going to say the batteries come off in purple and black to your battery. So we're going to hook up a battery here. Forgive my artwork. And we're going to call this 12 volts. So this inverter should have either a breaker or a fuse in it. Now, depending on how you want to do it and how your system works. Let's talk about a small system first of all, and then let's talk about a larger system. In a small system, you may do something as simple as this, where you're basically putting this on the terminal here of this battery and then connecting your cable here so that when that inverter is pulling that power or pushing that power to your battery, that this can protect you from that overvolt protection. This can give you, if your inverter shorts out or if a wire gets shorted out somewhere, it can protect your battery from just melting down and sending all that power through it or whatever the case may be. It can also protect it from being overcharged and too much power being pushed to it. And a lot of people ask me, well, how would that happen? Well, if you have, let's say you have 4 or 8 or 10 12-volt batteries running in parallel and you're charging like you have 8 or 10 12-volt batteries, and you have this battery has a limit of 100 amps, and 7 of those batteries get disconnected from a bus bar or a cable burns out or whatever, and this happens to be the only battery left, or you're doing some maintenance, the only battery left, but you forgot to turn it off, that fuse is the only thing that's going to protect that battery from just being hit with 800 amps of charge voltage. Now, most of your batteries, your BMS will protect you, but a BMS is not there for protection of you. A BMS is there for the protection of the battery, and it should be considered a last resort. You should protect the wires, and I'm going to say that again, the wiring of the system with your fuses and your breakers. Here's why. This wire, if you do not protect it, and that means that if you put a fuse in here, and you can put a smaller fuse if you have a smaller wire to protect the wire. And the reason being is that this battery could easily output more than 100 amps. And we've seen it in many battery tests where this could output, you may have a battery that can output 200 amps. But if your wire only supports, let's say, 100 amps, and you output 200 amps, what happens? Well, first of all this wiring, the casing around it, and all of this insulation starts to melt. First it heats up. Now, this particular wiring has a rating on it, and I don't know if you can see that. I'm going to put this over here on this one also. It has a rating for temperature, and this is 105 degrees at 600 volts. So this is a maximum. It should be safe up to 105 degrees. But if you take this cable, which let's say that it's rated for, and I don't know what it's rated for, if let's say it was rated for 100 amps, and you put 200 or 300 amps through it, and your breaker isn't there to protect this cable, your battery may be able to do that just fine. Your inverter may be able to do that just fine. Or you may have a short. But what you don't want to do is you don't want this to start melting, dripping on everything, and then start shorting because all of the wires are ran together in a conduit like this, or in some wrapped up in some shield, and now it starts to melt, and the plus and the minus connect together, and everything just starts to fry and melt and short out. That's what you're protecting. You're protecting this wire. Fuses and breakers protect the wiring around the devices. It's not there to protect it. Now, you'll hear me say, and I do it all the time, I always pick the lower of the evil. So if my wire can support 100 amps and my inverter, in the case of this one is, it is a 300 watt, let's see, 300 watts, and let's just do the math here real quick. So 300 watts, where's my calculator? There it is. So 300 watts divided by a 48 volt battery, so we'll call it 52.3, is 57 amps. So if I have a 100 amp wire, like I do here, then, and the inverter can't pull more than 57, and the battery can push out, if you've got a 48 volt battery, most likely the smallest I would connect is 100 amp hour, which would push out most likely 100 amps, would be maximum. Then everything here shouldn't go over 100. Now, let's say that I want to protect a particular device, and I know that this inverter shouldn't be going over 57. I may put a 60 amp fuse in on this over here to protect it, because I know if it pulls over 60, something's wrong, and I want to stop it as soon as possible. Undersizing it is okay in order to protect other items, but the main item is the wire. That's what you're trying to protect in this case. So we're going to put a fuse in here. We're going to call it right here 100 amp. Or now this is the basic rule here, is that you don't want a fuse or a breaker to pop unnecessarily. And what I mean by that is you don't want to have to go, and we've all had that house where you plug something in and the breaker pops, and then you plug something in the next day and the breaker pops again, and you plug something in the next day and the breaker pops again, and it's extremely frustrating to deal with. We've all had that scenario, and we don't want to do that. But at the same time, trying to find the window here, there it is. At the same time, we also don't want it pop, so you don't want it to pop for no reason. So the idea here is to oversize it by enough to handle small surges and short overages. And that's usually 125%. I think it was 125%, or is it 120%? And I had that actually in my notes earlier tonight, and I'm kind of ashamed to. And this is one of those that you can refer to the code book, section 705.12, and it does talk about 120%. So So you'd want to oversize this to 120%, and then of course you're going to have to go up to the next common size. They don't sell 120 amp breakers or fuses, but they do sell 125 amp breakers and fuses. So 125 amps would be perfect. Um, and that would allow for surges and everything to happen there. So we're going to put this little fuse right here at 125 amps, and then we're going to connect that to this. That would make that connection safe. Now, let's just suppose for a moment that I wanted to have more than one battery. And then that's where everyone says to me, well, now what are you going to do? So this is where you're going to get into what most of us refer to. I got this little bus bar here that I wanted to show you. And this is what you use to connect multiple devices to. Let me see if I got the screen on the right thing here. Let me see. There we go. Yep. So this little bus bar here will allow you to connect 1, 2, 3, 4, 5, 6 little connectors on here. Now this is an extremely small one. It is not made for that size wire or that kind of voltage, but they make bigger ones. This is just an example one that I brought. And it has a little protective cover and everything on it. But this would be where you would change this diagram to protect, and I usually end up putting in 2 sets of breakers in this case. So let's put in a second battery. So the second battery we're going to put right here, and it's going to have the typical negative side over here and the positive side over here. Now what I'm going to do is I'm going to disconnect this wire here, and we're going to install a bus bar. And we're going to run this one through the 125 amp and connect it to this bus bar. And we're going to run this one through 125 amps and connect it to the bus bar. And then we're going to take this one and run it over here. Now, the thing is that we've protected this cable and this battery from being too much being pulled. And we've protected this cable and this battery from too much being pulled. And now this bus bar should be able to safely provide 200 amps of power. So if I needed this inverter to pull more power, so instead of that being a 3,000 watt inverter, let's say that it was a 9,000 watt inverter and I needed 180 amps of power, then I could easily add another breaker right here for, let's say, 200 amps. Now, I'll make sure that the wire here can support 200 amps, but I can have smaller wire here that only supports 125 amps, and this one over here. That allows us to be safe all the way up, protecting all of the wire in this system all the way back to the inverter. Now, let's go over, that's going to be either fuses or breakers. Now, different people have different opinions on what they like to use. I would put in on this particular spot right here, this would be a breaker. Now, a lot of people, today I would put in a breaker. In my RV, I actually have a fuse there. I have I had an A&L fuse. I think I have another one now. Heck, I don't even remember. But you could put in a different kind of, I would put in one of the new breakers like I used in the 12-volt system, the one that you see on this screen here. Let me just see if I can show it to you. This one here. I would put like that breaker right there on the left, because that breaker allows me, and I know it obviously need to be bigger than that one because that's only 125 amps. But I would put in a 200 amp breaker in there to protect this one in that scenario in this case. Then these would both be fuses. Now the idea here is that the fuses should never have to go out. Now there is one downside to using fuses here instead of breakers. I still have no way to turn these batteries off. If I wanted to disconnect this battery, I have all the other batteries still connected to it. And so that still brings up a problem. And this is where you start getting into not all thumbs are fingers, but not all fingers are thumbs scenario. All breakers can have the benefit of overvolt protection, but all fuses don't have breaker protection, and vice versa. So you have to be very careful to think about what you're building, or you end up in a scenario where you put something like this together, and off the top of my head I put two fuses here, and now I realize by doing that there's nothing I can do to ever shut that bus bar off. It's going to have however many batteries connected, they're all going to be connected to each other no matter what. There's no way to turn it off. So the answer to that would be maybe you're better off putting in breakers here too. Whoa, what color was I using? This one. And that would allow me to shut this battery off, shut this battery off. Now, in most of your 48 volt batteries these days, like your EG4 batteries and those type of things, and almost all of the ones that I would have linked in this, in most of them, you're going to, and I'll turn back on that QR code for a little while in case you're interested in the links for these type of things. But you're going to have the what am I saying? You're going to have to make up the decision if you want to be able to shut these off or if they already have them built in. EG4 batteries have a breaker built in, so you don't have to put this fuse on them because they're already there. A lot of the 12 volt batteries out on the market don't have a fuse, and you will need to add a fuse to protect them from a catastrophe. Keeping in mind, you're not protecting them from everyday life. You're protecting them when everything goes to hell in a handbasket. When everything stops working the way it's supposed to, that's not something that you want under your bed or in the front of your RV without the protection devices. Please keep that in mind when you're working on these, is that you want to make sure you keep yourself and your family safe. And the only way to do that is to follow the rules and put the right breakers and fuses in there and get them sized right. So maybe I would change this to all breakers nowadays. And with those new breakers out, like the one that I have in that 12 volt system, they're very, very inexpensive. So I probably would just go ahead with breakers at this point. Now, um, this allows me to flip this off at anything, turn off the power here. Now, in the 6000 XP in the RV, this has a breaker, this has a breaker, and this has a breaker. And so all of these have breakers feeding into them as part of the default system when they come to you. I added this piece in my 6000 XP. If this was that particular setup, I added this here to, I think it's a 250 amp breaker here, or fuse there. And I have a additional DIY battery over here, and on it, it didn't come with a breaker. All it had was the BMS, and because the BMS is only a last resort, it is not a safety, not there for your protection. It's just there to protect the battery. I added a T-class fuse. All fuses and breakers have response ratings. We talked about these types reacting to heat, but they take a while to heat up unless you really overdo it. Um, T-class fuses are very, very sensitive. The little element that's in them, like in this one here, and I can show you this element on this other camera, the little element that's in here, like on this one here, will burn out. But because that is still so close, under high voltage, it could not only burn out, but it could continue to arc across that and still send power to whatever device it is and cause either your arc protection, your arc fault protection to trigger and shut down your system because of arc fault, or it would just jump across this and continue running all your devices and just short out. And this fuse would do you no good if this fuse isn't rated high enough to do that. But if you, in a T-class, this element is surrounded by a sand-like device, and that sand would smother that arc out and prevent this from continuing to arc, and it would help smother it. And that's why you have the T-class. In addition to that, they are extremely fast-acting. In other words, if you reach out to touch something and it shorts, the last thing you want is for it to short and take its time heating up a little element inside of a breaker before it says, okay, that's hot enough. I think his arm is crispy enough. We can shut it off. You want that T-class fuse to pop. So I put that in my DIY battery over there. Let's move on. So that takes care of your battery side of things. So let's talk about the PV side. And I'm going to put PV up here because I want to deal with the AC piece of it down in this corner down here. So let's talk about the PV. And we have, again, a positive and a negative. And as you saw from the picture, this needs a disconnect. Now, there are times to use fuses and there are times not to use fuses. So let's talk about a simple system first, and then I'll get into a little bit more elaboration of the complexities of it. And I'm going to need a paper towel to erase some of that. So excuse me while I step off screen, sneak behind the coffee counter, grab myself a paper towel. Wish I had time to make a latte. I can make all of you guys a latte to go with it. All right. So let's look at on the PV side of things. It is DC just like your batteries, but it is a fluctuating voltage. So you have power coming in based on how bright it is, what kind of solar panels you got, whether you have them in parallel, whether you have them in series, and this also determines what kind of safety devices you need. So let's talk about a very simple system first. Let's just put a single panel right here, and we're going to take this single panel and we're going to run it into the positive side over here and the negative side over here. It's very simple and straightforward. Now, what kind of devices do you need? First one is the code requires that you have a shut-off device in here. This is not a breaker, it's not a switch, it's not an overprotection device, it is a shut-off. You need to be able to turn it physically off so that it is not coming in there. Now, a lot of the inverters come with this. A lot of them don't or didn't used to, and a lot of the new all-in-ones come with this shut-off device. And you'll see it on my picture here in the solar shed. The shut-off device is that big box on the right-hand side with the two MC4s coming out the top and two MC4s coming out the bottom. Now I'm going to see if I can possibly bring that, make that a little bit bigger, smaller, I mean, so you can get an idea. There we go. So you can see there we have two devices coming out of the bottom and two devices coming out of the top. That's the negative comes in from the bottom, and the positive comes in from the bottom, and that's from the PV panel side, and then it goes out to the charge controller on the top side there, and you can see it runs straight into that charge controller. Now, this shutoff is not overvolt protection, but it was a single panel, and in a single panel you need to put the shutoff here on off. But you do not need to have a fuse, and let me explain why. If a single panel being here shorts out, all it's going to do is short out and stop working. There's no other source of electricity other than its own generation, and therefore it won't short out. Now, if you look at a solar panel sticker, it's going to have a short circuit amount, and that means that if it's under that amount, that it doesn't need, if the alternate energy coming in is under that amount. And so let's say you had two panels instead of one, and let's say they were both 8 amps for argument's sake, and you were going to run them in parallel. So you connect them up like this, and that means that this line has 16 amps going down it, and it goes through the shutoff and goes in here. Now, this panel most likely will have a 16 or 18 amp rating for you need to fuse it at this point. And what it's saying is that if there is an alternate power source of over that amount feeding the short after when it starts to short, that you need to put a fuse on it. And this is why I'm saying this. So with one panel, this has 8 amps and it shorts out and it goes sour. Now you have this one constantly feeding it 8 amps, but it's rated to handle up to, let's say, 15 amps. But a lot of the times it's right around 15 amps that these panels list that rating for. And I wish I had grabbed a sticker to show you guys. So that 15 amps and these two 8 ampers, the 8 amps comes in, turns into 16 amps, goes to the shutoff. But if this panel is to short out, it only has an additional 8 amps of power to feed the short. And what I mean by that is if the power doesn't go this way, it's going to continuously go into that panel and short out. But it's not going to have enough power to do a significant amount of damage. Therefore, they say you don't need it. Now, if you put 3 panels in this string, and they're all 8 amps, and they're all ran in parallel, now you have a problem. Because this panel says that if you need to fuse it at 15 amps, and if this one shorts out, you have 16 amps of power constantly feeding the short in this panel that it cannot handle. It's too much power. So at that point, you would need to put a inline fuse for 15 amps, protecting it from other panels feeding the short. When it's the only thing, it's designed to handle up to 15 amps of short. It's not designed to handle over that. So as soon as it goes over that, it can cause a problem. Now, this is a couple of little panels example, and it's very easy to say, yeah, but that's not very much power, and it's not going to be really blah, blah, blah. And you're most likely right. And I lost my napkin to clean. Oh, there it is. Um, but let's look at a scenario where it's a little bit different. Let's say you had 2 strings of, let's say, 8 panels. And these 8 panels, and then you had yeah, you have another one of 8 panels, and another one of 8 panels. So you got 24 panels in your thing, or even 30 panels in your series. When these all feed down, if a panel over here shorts out, not only do you have only the one panel here that has the problem, but you have all the other panels, plus all of these panels, plus all of these panels, all feeding back to this to cause you problems. So you're going to want to fuse that to prevent, and you're going to want to put that fuse in here to prevent that power from feeding from all of these up into that string and feeding that short circuit a constant source of power that never shuts off. And that's when you're going to need to put in your fuses on your solar. But you always need to have the shutoff. If it's not built into your all-in-one, then you need to put it in here. This can be, they do sell some dim switches that are like these here that can be used for this. The inline ones or the MC4 connectors are much easier. You can just put them anywhere in line. And I actually haven't hooked up any of these to be these fuses yet. I've only used the inline ones. But you can do these as long as they're rated correctly. They're the right voltage. they're the DC rated for the right amperage and everything that you need, and that they can handle the arc. That's going to be the big one. You need to make sure that they're big enough to handle the full amperage that can be put out by those panels. All right. Now, now we've talked about the batteries, the different when you need the fuses there. We've talked about the shutoff switch here. We've talked about the fuses that need to go in the panels. In a lot of the times, there is, I put on my DIY battery, I put it on another shutoff switch so I can isolate it from my 3 EG4 batteries, because my EG4 batteries had shutoff switches in a breaker attached to the actual case. My DIY battery did not. And even though I put a T-class fuse in there, I didn't have a shutoff switch. So I put one of those shutoff switches and I put the T-class fuse in it. So it's the combination of these devices depending upon what you need. Some of them do multiple items, like this is overprotection and a shutoff switch. And some of them are single purpose, only a shutoff switch or only a fuse or only, and usually the breakers are multi-purpose. Now, let's talk about the third piece of this, and this is all the DC current that's coming in. You've got the PV panels coming in DCs at higher voltages. You've got the batteries at a lower voltage than this, and it's much more consistent. Now we're going to talk about the AC side of things. So on the AC side of things, and especially in the diagram or in the one that we're using here, what is this? The inverter we're using here. Sorry, I'm starting to lose my voice. Okay, so in this inverter here, you can see here we've got two different types of power coming in, or two types of AC power, I guess I should say, not two types of power coming in. I'm going to turn that a little bit so we can get a little bit better view of it. And what this allows you to do with this inverter, if I could hold this camera still for you, is it allows you to plug in a wall outlet coming in. So you have a neutral and a line in, and the connectors go directly into here, just like any normal wall outlet. I usually just take an old wall outlet that I've got, or I even ordered a pack at one time of a pack of 4 that were just had cable ends on the end, and I just put used a simple pack of these to just cinch up all of the connectors and make the ends more like these here, so that you could put them in and bolt it down nice and safe without having to worry about all the stranded wires getting out and running around all over the place. And this little kit here, I think I bought this on AliExpress for like 89 cents or something. I ordered like 3 or 4 of them, and they're really easy. You just put them on the cable and you can just tighten it down. There's a little crimping tool, and even if you don't have the crimping tool, you can go ahead and put them in, and once you tighten it down, it crimps around the cable and holds it all together anyway. But that's probably one of the easiest investments, the best investments that I made was just buying a box of those. So that allows you to hook power coming in. That is also, if you're plugged in, that is also where you're going to want to get your grounding source. And your grounding source for this, and that will run both the ground for this side and the ground for this side. All of them connect into this. I'm a little puzzled that the grounding source here is a single grounding source, that they didn't do it. But even in their directions, they show both the grounds from this in and the out going over to this source over here, because it is a common ground and it should be a bus bar. And I think what it is when these inverters were designed, the DIY market was much smaller and less complicated than it is now. Now they're putting in bus bars and all kinds of stuff in these with shut-off switches and everything. This one, instead of having an actual breaker and stuff, just came with this breaker. Now you order like a 6000 XP and it comes complete with breakers all in it, built into it, PV shut-offs and everything. So here we would hook up both I'm assuming that when you plug this in, that there would be a an outlet that you're plugging it into, or a breaker feed from a panel somewhere. That would be the actual breaker that you would need to protect this side, because you're protecting the wire from that source to this device. So there's source of where you're getting that power from, whether it's a pedestal when if you've got this in an RV, or whether it's a wall outlet if you've got it hanging in your garage, or whatever it is, that would already have a breaker there. So that side's done. This side is where things start getting interesting, because this is where people leave out the safety device, and it causes them more trouble in the future. If you do not hook up a breaker here or some kind of protection for power, you can short this out directly, and it's not going to shut off until it has all that power going out there and all your wires melting and everything else. So you need to be very careful that you connect this to something along the lines of the devices that either a breaker or a something like this. Even this one here is perfect for that, because this is AC and DC rated. So you could order a breaker like this where it's 240 volt, maximum 240 volts, 125 amps. But this is a little bit big because it is 125 amps. You need something smaller. This is a 3,000 amp or 3,000 watt inverter. So with a 3,000 watt inverter, you really need something that's rated around at 120 volts. You're talking about a 25 amp breaker coming off of this, and that would be where your maximum you want for that to short off. So you could run a 20 amp breaker. You could also run into a box that allows you to feed multiple wall outlets, and there's a lot of those available, and I'll link one of them in the description later. That power, it's almost like a power station where you could run a wire from this into that, and then it splits into 4 plugs, and it has breakers and everything in it that you could use to protect your source and your power there, which would be very good. And then of course we talked about the PV. So let's put these up on the board, and we'll just draw them out, which ones which you would need for what, because there are 2 different outputs here. Or actually there's an input and an output. So the input would come from your input would come from a wall plug, and I'm just going to label this in and out. Now on the in, this would actually hook up to a wall plug that you would just plug into a normal house outlet that you have, and it would be no surprise. My art's not getting any better, guys. Sorry. But that would allow you to plug it into an outlet and use the bypass features, charge the batteries if you need it, whatever options you want it to use the power in for, whatever that particular inverter can have. A lot of people have free power in the middle of the night, so they charge their batteries in the middle of the night. Other people use it for emergency backup of charging their batteries when there's no sun or whatnot. Some people hook them up in RVs, and when you get to a pedestal, they plug it into the pedestal and trickle charge all day, or at least run all their devices. The outside, I suggest that this runs to some kind of breaker box. Now I'm going to call this a breaker box only because a lot of people don't want to hook an inverter, in a small inverter, let's say a 1200 watt or a 2000 watt inverter. You can hook it to a single wall plug, and that would be perfectly acceptable. I mean, a 3000 watt inverter is only 25 amps. So if we go to a 2000 watt inverter, we're looking at 16.6 amps, which is basically a 15 amp breaker that you would have, a normal 15 amp outlet that you would have in your house, minus some of the surge capacity that you might run into need to deal with. But this could allow you to have multiple outlets powered by the output of this. For example, in the case of my RV, this is outputs, and there is two. You believe there is a push button on the bottom of the, and I think what you're talking about, you're probably right on this particular inverter. Let's just take a look at that real quick. So what he's talking about, and sorry, I forgot to bring your comment up on the screen. Let me do that so that everyone knows what I'm talking about. Sorry about that. Let's just, there it is. This. I think that should have got it on the screen. Well, at least I thought it was going to get it on the screen. Oh, I see what I did. Okay, give me just a second, guys. There we go. That should have done it. There we go. So I believe there is a 20 amp push button breaker at the bottom of the inverter. And the inverter that we are discussing today, which is the that I'm using as my demonstration, absolutely you are right. And I hope that will stay. Oh, it will. Good. So that comment does stay on there while we look at this. So what he's talking about is that this particular inverter does have, I'm going to pull back here a little bit so you can see it. So this is an input breaker. And I believe this is for incoming power though. I don't know that it has an output breaker. It has an off on, but I don't see an output. I see a ground. It says press to reset breaker circuit. So it does say input breaker, but I'm wondering if that is for the output line or the input line. It would be kind of odd that they label it input and it be for the output line. So, but a lot of inverters do have it. For example, if I go hunt down like, let me just go grab like the 6000 XP and just get you a picture of that. Let's see, here we go. So here on the 6000 XP, if you have, let's say you have 4 or 8 or 10 12-volt batteries running in parallel, and you're charging like you have 8 or 10 12-volt batteries, and you have, this battery has a limit of 100 amps, and 7 of those batteries get disconnected from a bus bar, or a cable burns out, or whatever, and this happens to be the only battery left, or you're doing some maintenance, the only battery left, but you forgot to turn it off. But you can see fuse here, is the only thing that's going to protect that battery from just being hit with battery 800 amps of charge voltage. And here are the outputs. Now, most of your batteries, your BMS will protect you. Built in. BMS is not but it's got bus bars for the neutral and for the signal. So every inverter is going to have is there for the protection of the battery, and it should be considered a different group of breakers, switches, plugs, that kind of thing. The thing that's important to recognize is to recognize which ones you do have and which ones you don't have, so that you can identify which ones you need. And that's what's really tricky about this. Is it doesn't. It's not. I don't. It's one thing for me to just tell you, hey, here's what you need. It's completely different to show you how to determine what you need and to have confidence that you've got it right. That's what's really important. So we'll take this board back to here, and I group my receptacles to the ground screw on the bottom. And that works also. So what he's talking about here is on this bottom piece here, there is this ground, and that is connected to the same ground as this one over here. So this is the input coming from the output, and then that is connected to this. Now, I don't know if the case, and it would be interesting to see, and I've got a meter with me, I'm going to find out, is the case bonded to this ground here, to that ground there? So the easiest way to test that is we're just going to take us a meter here, And so you can see when I touch these connectors together, it beeps. Hopefully you can see that. Oh no, you can't see that. All right, let me just put this in a place where you can see that. I'm just propping it up on some trash bags and stuff behind it. So sorry about that. Let's see if I can back this up a little bit. But this is how you can see if things are connected, is this just beeps when they're connected when doing a continuity test like this. So if I connect this to this, you can see those are not, oh yes they are. Those are connected. It should not be connected to any of these. But those two are connected. That's good, which should be connected to any of the other metal parts on the case that I can actually get through that coating. So all these screws and everything are connected, and that is connected. So if you connect the ground here coming from the grid, then you would have, this would be a valid ground, which is good. And that's how you can confirm what it is. Now I've seen, strangely enough, I've seen a lot of this one here for the output goes directly to this and then put two lugs in here. I'm not even sure if that passes code putting two lugs in there or not. I'm really surprised they didn't put some kind of, I guess the newer versions, the 6000 XPs and stuff, they do put an extra, what is it called, a breaker bus bar and stuff like that. This 3000 is a much older machine, but it's still a nice one though. It's really, that's why I've got one for it, is to hook up in the solar shed as we start to rebuild with this new solar shed that's coming. So anyway, um, yes, it is. That is the input. But here's the thing that's important about ground. Ground is shared throughout your system. From the input is the best input the input is the best ground that you could have. The one that comes from the grid is the best ground that you can get. That's grounded to your panel, which is grounded to the pole, which is grounded to the earth, which is grounded with a rod and the whole bit. Otherwise, if you don't connect it to that, you have no ground. All of them may be connected, and it may stop just a simple short, but there's still no ground. So you're still going to want to make sure that you have a ground connected, and that gets into a whole new conversation. But grounding is something that's not something you want to skip, and that means if you do not have the grid connected, you need to determine what do you need to do to actually have a proper ground connected to this device. That means there should be a ground in that grounding plug, regardless if you have AC voltage coming in or not. Something should be grounded there, whether that's your own grounding rod or whether that's running to a different grounding rod or whatnot. But that's not something that you should skip. Figuring out the right grounding is very important. Okay, so this could go into here, and then obviously ground is one of those items that we left out of this chart, but I want to make sure that I highlight that point now. When this comes from this plug here, which runs down to here, it should connect to this output also, to this output, and to this device, to your solar panels, to your, but usually your battery cases need it. A ground is a leveling point to say this is zero. This is where the voltage starts. And voltage isn't always starting from 0 and going up to 120. It's starting from two different points. And if you measure, and you can take a meter and you can measure in line halfway through your system and halfway through another system, and it will tell you the voltage between the two because your starting point isn't 0. And that means that if you don't have a common ground throughout your whole system, you may have, 120 starting from 10 volts over here, and it actually be 150 or 160 volts. It just depends. So grounding is very important, that it's one shared connection all the way back to where it connects to your main panel or to that grounding rod. And nowhere else should they connect, but they should all be tied together in a single connecting big puzzle here. the the trick is to give that current a way to flow back without going through all of your devices and connecting to all of your items and everything. When something goes wrong and something shorts out up here, you want this to go back through that green wire all the way through without getting mixed up with your other wires, because your other wires go through channels within your device that burns things out and causes things to snap and fry. And that's what you're trying to prevent there. Okay, I think we covered everything. Did I miss anything? Is there anybody that has any questions? Even more importantly, quickly went over grounding, which is good. I wasn't expecting to cover grounding, but I'm glad I did. Um, all right. We have NSS did, he also put you into your grounding receptacle out there. And yes, that is the input. I think I answered that, but hopefully that made it clear. And I think that is everything. Did I miss anything? Does anybody need anything? I will take all of the links from tonight's show. I'm sorry I have not put them into the show links. As soon as we disconnect and I hang up here, I will take them all and take them off of um, uh, the link that's included there with that scan code. So if you scan that, it'll take you to a web page that has them all in there. I just forgot to copy them into the show notes. That's attached to the YouTube video. And then you'll be able to get them from there. And it'll be available immediately following the show. Um, I think that's it for this weekend, or for this week. I'm not sure how everyone feels about Monday night. I would love to hear your feedback. I did this Sunday at 4 o'clock for months and months and months, and then was forced to rearrange it and do a Sunday, or excuse me, a Monday one, and it worked really well for me. And so I thought, well, you know, if it seemed to work really good for you guys also, so I thought I would ask and find out if you're interested in doing it, if you would prefer to have it switch back to Sundays or keep it on Monday. So please feel free to just let me know whatever your opinions are. Right now, my intention is just to leave it here on Monday for a while and see how it goes. And if it works out, then we'll leave it here until it doesn't work anymore. Anyway, um, thanks for coming. I do want to do a few celebrations here. Let's see what we've got going on with everything. So we are looking at, if I can get a browser that can work. There we go. All right. So we are looking at this week. We are sitting at 16,290 subscribers. Thank you guys. Thank you so much for subscribing. And to all of my members, I know I've given you a huge influx of videos lately. It never stops. I am constantly working on new videos. I have an enormous amount of new content coming. It's for those of you who don't know, I am moving from where I'm currently located in my RV back into a house that I had rented. I got it back after a couple of years, and now it needs a lot of work. And so I'm going to go there, and you probably saw the video on it, me talking about the solar system that I had there and professionally installed, and some of the regrets I had with that. If you didn't, it's a great watch to get an idea of what a professionally installed system can look like and cost. Or at least what it did several years back. Things have changed quite a bit, but still very expensive compared to DIY. And then I'm going to be rebuilding the solar shed in a much bigger version. I got something coming out on it. So we will be building between 12 volt systems and 24 volt systems and 48 volt systems. I don't miss anything. I keep them all in the schedule. I've got some bunch of battery reviews coming out. I've got a bunch of big 300 amp hour and 280 amp hour 12 volt batteries coming. I'm going to build some Frankenstein 48 volt stuff to run some of these things just to kind of give it a test. We're going to put a couple of the 12 volt batteries together and run them to do that. Obviously, you saw everything I did on the solar shed with the 12 solar panels coming in and feeding a 12 volt system, how it was much more efficient doing them in parallel as opposed to serial because it had to feed the 48-volt system, which made 24-volt system very appealing for smaller systems where you need it. I've got some EcoWorthy sent me some new panels to test. We're going to try some of those out. And then we're going to just basically keep up playing with things. And we may even over the next 6 or 8 months hook the house up through the work with the company that runs the warranty and figure out how we can hook up a battery and go into getting it to operate off grid as well as only on grid so that it doesn't shut down when the power goes out, which would be a lot of fun. And at the same time, as I said before, when all of this started, this is an optional even if you are DIY. DIY doesn't mean we're stupid, doesn't mean we're going to burn our houses down or do things wrong. The NEC code is here to protect us. I am going to take that mantle up and bring us the most important aspects of this as those code changes come in and try to relay some of that information to you guys as best I can, keeping in mind I am not a substitute for an electrician. If you're not comfortable doing anything, please don't hurt yourself. Call an electrician, get them to help you. They'll be glad to do it. It'll be worth your money and your time. And again, thank you for subscribing. Thank you for being a member. Thank you for watching tonight. We'll see you next week. For those of you interested in getting a one-on-one solar class and learning about the solar systems in vivid detail, this week was a presentation was based on what comes in chapter 5 of the solar class, which is a 12-week class that covers every aspect of sizing, building, managing, constructing, installing, and everything that you could think of for solar panels. So I will show you the promo video for that following this, and hopefully we will see you guys next week. Thank you, NSB. I appreciate it. Thanks for watching. Thanks for being here, guys. And this confetti is for all of you just for being here. Thanks. I really appreciate it.
Over the last couple of months, I have shown you a lot of different solar builds. We have done everything from a $180 solar shed to the solar shed version 2 that had the solar 12-volt solar system built into it, to an RV 48-volt system, a DIY battery, or even my wife's coffee trailer setup. The one thing I keep hearing over and over from you is that I want to do this myself, but I don't know where to start. So I built something for you. I'm calling it simply the DIY Solar Class. It's a self-paced, approximately 12-week step-by-step course that shows you how you can design, wire, and power your own solar system the right way, the safe way, and without wasting a whole bunch of money the first time around buying things that you don't need. Learn from my experience. Each week, the curriculum focuses on one of the components in a solar system, either that be panels, batteries, inverters, wiring, real builds, real life situations, real designs, with all the details, with diagrams and videos so that you can follow along. I built this class because I remember when I first started how confusing my first solar system was. I didn't understand amps, I didn't understand volts, I didn't understand wire sizes. I understood electricity a bit, but fuse ratings confused me. Different types of fuses confused me. There was so much information overload that putting it all together with a random selection of videos out on the internet was very difficult. So this class is intended to put it all together. It takes everything that I've learned from dozens and dozens of builds and all the mistakes that I've made along the way, and there have been a bunch of them, and turns it into one complete roadmap that you can follow step by step and get the information you need. So if you've watched my videos or wanted to build your own system,
This is how we can do it together. Let me give you an idea of what is included in this class. So you're going to get a step-by-step video lessons for each part of the solar system. Printable diagrams and parts list. Either you can follow them exactly, or we can work together to modify them to meet just your specific needs. We'll do a live Q&A session every other week just for the class so that everyone gets all of their questions answered. I've also included a one-on-one call to go over and to review your designs or just talk about what your solar system is involved and make sure that you're comfortable and have all the questions you need in that one-on-one setting. Not only that, but you're going to get lifetime access to all this content as I update it as we go along so that you can go at your own pace, come back at any time to refresh, and when I add new content, you already got it. You can always come back and pick up where you left off or rewatch the entire course anytime you want. If you've been waiting to build your own solar system, if you're looking for the perfect gift for someone who wants to build a solar system, if you want to put solar in your shed or on your RV or take your house off grid, this class is for you. This is why I made it, to give you that one-on-one help to make sure that you do it right and you do it safely. Founding members right now, between now and the December 31st, get 50% off the class. Starting January 1st, the class goes to full price. So right now, if you sign up, you get it for half price. That's a lifetime membership. You'll never be taken out of the class. You can join the day at mattmansolar.com/class or click the links below. Either way, I'm going to keep teaching on YouTube. I enjoy it way too much. But if you want to go deeper, if you want to know exactly what you need for your system, this class is for you. If this sounds like what you've been looking for, head over to mattmansolar/class or just scan the QR code on the screen to grab your spot. Founding members get 50% off through December 31st, and we kick things off on New Year's Day. I'd really love to see some familiar names from the comments inside and help you design, build, and update your